Okay, so tell me about your project.
So basically, we're trying to take a picture with a scanning electron microscope of a pure culture of ehucs, but we're trying to take a picture of only. At first, we were trying to take a picture of maybe one or two cells. We've decided to go with taking a picture of the culture of ehucs, which is living with other algae such as Anabina and some other algae we're not certain of. So basically, what we've started off doing is diluting a culture that we already have of Gulf of Mexico water, and we're doing a serial dilution of several samples up to about 10 to the negative 7. 7? 10 to the negative 7? 6? And after that, later today, we're going to look at, under a microscope, those dilutions and see if we've gotten a good culture of ehucs, or either a small culture or a culture that's a pure culture of ehucs. But we're assuming it's going to be a small culture of an ecosystem of algae, hopefully with ehucs. And once we get that, we would start a process including dehydration, fixing, and sputter coating, which Anna will go in detail.
Okay, so why are you interested in ehucs?
Well, first of all, it's the most prevalent algae on the planet as far as some research that I've looked at goes. It produces a lot of omega-3 oils, which over time can turn into usable combustible oils, but after millions of years. We think a lot of the oil that is used by our vehicles today is produced by algae, but more specifically ehucs, over a long time. Also,
So this could be used maybe for biodiesel?
Yeah,
okay.
That is one of the options.
We'll just try to speed up the process, okay.
And also, it acts as a carbon dioxide sink, if you will. It takes a lot out of the atmosphere, and it's helping contribute to a better environment for us to live in as we continue to pollute the world.
Okay, so ehucs is going to solve our...
Possibly, if we know how to grow it properly. Okay. And that's one of the things we still need to learn how to do in this project.
Okay. And so Anna, tell us about what the plans are.
So the preparation of samples for the scanning electron microscope consists of several steps. The very first one is fixation, and it's basically what I've learned in the research about it is that it's a lot of trial and error, and that's why we are just gathering information. And what we've learned so far is that there are certain chemicals, fixatives, that have been commonly present during the process. We're going to be using glutaraldehyde as our fixative, and that just consists of a few steps. Probably will take a day. After that is dehydration, and that consists also of several steps. After that is drying, and then the very last step, sputter coating with the sputter coater. And we're going to be using gold.
And then we get to put it in the microscope.
And then we get to put it in the microscope.
Okay. Okay, so you guys have run into a few problems here, huh?
Yes. So our biggest problem was trying to figure out how to get the sample collected where we didn't have too much of a sample or too little of a sample. We've tried different growth methods, so dilutions, and how to collect it. And what we probably come up with the best is to serial dilute and then collect and centrifuge so that the sample will go to the bottom and we can collect. We probably won't get a pure sample, but we'll get an ecosystem that we can observe and then go from there to try to figure out why it's so hard to get it purified. So
okay, so you've been trying to grow just straight ehucs, and it comes from the Gulf of Mexico as part of an ecosystem?
Yes. Very
so it doesn't matter what starvation or overfeeding, it doesn't matter what methods we tried, that whatever is happy with it. It all has the same survival mechanism. So it's all
Okay, so-
shutting down together and coming back together. And it seems to like its
Being
ecosystem. So we have to determine whether that ecosystem is absolute or whether it can be on its own.
Yeah, so for the EM, it's not necessary to get a pure culture, but
No, but
if you're gonna use it as feedstock for biodiesel, you'd like to have as clean of a pure sample as possible?
Yeah.
yes.
Okay.
And it may just come down to controlling the growth of the other algae because it tends to grow at a faster pace than the EHUX.
Oh,
So
because
if
some
we
of
can
them are
slow
the
it down-
cyanobacteria that are bacteria
Yeah.
that
So if
can
we
divide much
slow it
faster.
down instead of eradicating it, maybe we
But
can
then again, we're not
pull
sure.
out the EHUX with a density centrifuge.
But then again, it's likely that EHUX grows best with other things rather than on its own. So what you could do is just grow a large vat of a mixed culture of different algae and other organisms. And then after you've grown a huge culture, you basically get rid of the other algae
Through
Then-
possibly density centrifuging
or changing pH.
and then
Because
selecting.
EHUX is also known for being very adaptable to its environment.
Okay, so you may be able to kill off the rest of them before you
Because
harvest.
For a culture a while ago that me and another professor, Johnson, did, we starved EHUX that was in a mixed culture of other algae and bacteria from the Gulf of Mexico, and everything else basically went into hibernation or died. And you actually see EHUX is the only thing visible under a light microscope, and they're just, you can see millions of them everywhere.
Okay,
As soon as we started feeding it with Miracle-Gro, greenery of other organisms
Great.
exploded.
okay, is EHUX green?
No, it's like, it gives like a
Golden
gold
brown.
color. It's a
Oh,
gold
all that
color,
oil.
Possibly.
Wow,
But under
cool.
the light microscope, it is gold.
Okay, so
brown
you
gold.
can't see it.
And
okay.
yet under oil lens, you can see, we think we can see the shell that it's in,
And oil.
Okay.
Yeah, you can see.
Calcium carbonate.
You can tell the difference
the coccolith.
on the coccoliths and the color because like we've had some that are just brown and have like this dark circle around them. We call it circle of death.
But
And then there's some that we've looked at that's had a little more access to food and it has like a red-blue color in the holes. So
Cool.
we can see that. We have images.
yeah, so it's like an overall a goldish hue, and then you see dark brown design. Like it's like a pattern, dark brown dots. We think that's the coccolith wrapped
Okay.
around.
Okay.
And that's we think it's used for concentrating light on, it has among multiple uses. It's used as to concentrate
A
a
light
lens to concentrate light on a chloroplast.
light
Wow.
concentration for photosynthesis.
Okay.
Yeah. And there's many more things that can be
Yeah.
used for
We could go on.
commercially.
Okay, but- so you've had a plan, had a few problems, and now you're in problem-solving mode.
Yes.
Okay.
Yeah.
And now we're hopefully within the next 2 days we'll be in go mode.
Okay. Good.
So
All right.
Thank you.